Welcome back to Dr. Fogg's TV.
Good day everyone, I remain your humble Dr. Fox. So today, we're looking at physics, that is linear, area and cubic expansivity. The cubic is also called volume expansivity. So before we take a look at our questions, let's discuss linear expansivity. Now, linear expansivity is the increase in length per unit length per degree rise in temperature. Or you can say it is the change in length per unit length per degree rise in temperature, and it is measured in per Kelvin, represented with alpha. So here I will come here and say that linear expansivity is the increase in length, that is delta L, per unit length per degree rise in temperature. So I can call this my equation 1. I will move again. I will say linear expansivity, change in length or delta. When you see delta in front of a parameter, it means there are two things involved. That is final and what? Initial. And the final carries 2, initial carries 1. Here becomes L2 minus L1 over L1. I have my theta 2 minus theta 1. This is equation 2. We move further. From here, I will say from equation 1, make delta L, that is change in length, subject of formula. If I make delta L the subject, alpha is change in length over L1 delta theta. Now making delta L the subject, it becomes change in length equals to alpha L1 delta theta. I'll call this equation 3. And I move further to say delta L is simply alpha L1 theta 2 minus theta 1. I'll call it equation 4. Because change in theta, that is temperature change, is theta 2 minus what? Theta 1. Now, we move further again. I will come here, I will say from equation 2, make L2 subject of formula. So if I make L2 the subject of formula, I have alpha equals to L2 minus L1 over L1, and I have theta 2 minus theta 1. Then from here, if I'm making L2 the subject, it becomes what? L2 minus L1 equals to alpha L1 delta theta. Don't forget that theta 2 minus theta 1 is the same thing as delta theta. So from here, I have it to be L2 equals to L1 plus alpha L1 delta theta. L1 is common, so this is L2 equals to L1. Here becomes 1 plus alpha delta theta. I'll call it equation 5. So these are the formulas we need to solve linear expansivity. So when you are asked to calculate, it's not out of these formulas. So when we are done calculating for linear expansivity, then we'll move to area and cubic expansivity. So very quickly, let's move to our number 1 question. So before we move to our number 1 question, don't forget that alpha is linear expansivity, L2 final length, L1 initial length, delta L is change in length or increase in length, then theta 2 is final temperature, theta 1 is initial temperature, then change in theta is delta what? Theta. So that is that. Then to get the units, don't forget that alpha is delta L over L1 delta theta. Change in length is length, that is meter. L1 is meter, and temperature is what? Kelvin. This cancel this, it becomes what? Per Kelvin, because it is 1 over what? Kelvin. So let's put one question. It said a metal rod 800 millimeter long. That's my L1, 800 millimeter, is heated from 10 degrees Celsius to 95 degrees Celsius. That is theta 1 is 10 degrees Celsius and theta 2 is 95 degrees Celsius. If it expands by 1.36 meter, for something to expand, that expansion is not the real length, that is the change in length. So that is what delta L equals to 1.36 what? Meter. For example, if the length of this marker is 10 centimeter and I extend to 15, that means what? Change in length is what? 5. That what happens here, it expands by 5. What is the linear expansivity? I'm looking for the linear expansivity. I know my formula is what? Linear expansivity equals to delta L over L1 delta theta. So linear expansivity, change in length is 1.36, then divided by 800, then multiplied by 95 minus 10. So here becomes 1.36 over 800 times 95 minus 10 is 85. So here becomes 1.36 over 800 multiplied by 85. That is 68,000. So here linear expansivity becomes 1.36 divided by 68,000. That is 2 times 10 raised per minus 5 per Kelvin. That is that. So number two, the length of a zinc rod at 23 degrees Celsius is 200 meter. The length is L1, 200 meter. Then at what? Theta 1, that is 23 degrees Celsius. It said the length of a zinc rod, when the temperature, that is the first temperature, 23, and the first length is what? 200 meter. Calculate the increase in length, that is delta L. Like I said earlier, it's called increase in length or change in length. When its temperature rises to 33 degrees Celsius, the temperature, that is theta 2, becomes 33 degrees Celsius. And the linear expansivity of the zinc is 2.6 times 10 raised to minus 5 per Kelvin. Don't forget that the formula is linear expansivity equals to change in L over L1 delta theta. Now, I am looking for change in length. I will now say change in length equals to alpha L1 delta theta. Change in length is equal to alpha L1 delta theta. So my change in length becomes here is 2.6 times 10 raised to power minus 5 times the L1 is 200 multiplied by the what? Temperature, that is 33 minus 23. So my change in length becomes 2.6 times 10 raised to power minus 5 multiplied by 200 multiplied by 10. I now get 10. 33 minus 23 is 10. So my change in length, now when you are working with standard form, you don't touch the power, you only deal with the base. So here I'll just do 2.6 multiplied by 200 multiplied by 10. That is 5,200 times 10 raised to power minus 5. So this is 5,200 times 10 raised to power minus 5. And then I will convert this 5.2 to standard form. Now, don't forget, the rule of standard form says that wherever your point is, your point must migrate to stay between the first and second number. Wherever your point is, it must migrate to stay between your first and second what? Number. So which means that change in length here. Now, since there is no point between the numbers, it means my point is after the last number, which is my point is here. So I move my point 1, 0.23. That becomes 5.2 times 10 raised power 2 no raised power 3 minus 5. I move the points 3 times to stay between 5 and what and 2. And when you're moving your points from right to left, your power becomes what? Positive. Then from left to right, your power becomes what? Negative. Then the minus 5 I add them initially. This is it. So my change in length here becomes 5.2 times 10 raised to power minus 2. So my change in length becomes what? 0.052 meter. That is the answer. 0.052 meter or 5.2 times 10 raised to power minus 2 meter. That is question 1 and question 2. So move to question 3. A metal rod 500 centimeter. 50 centimeter. That means my L1 is 50 centimeter. Is heated from 40 degrees Celsius to 80 degrees Celsius. Which means theta 1 is 40 degrees Celsius, theta 2 is 80 degrees Celsius. If the linear expansivity of the material is alpha, linear expansivity is C alpha, then they say calculate the increase in length, that is delta L, of the rod in meters in terms of alpha. So I'll calculate in meters in terms of alpha. So which means that I have to convert my L1 to meter from centimeter to meter, because the question says calculate the increase in length of the rod in meters, which means that my L1 is 50 centimeter to meter. So L1 becomes 50 divided by 100. From centimeter to meter divided by 100. The 0 cancels 0. L1 becomes 0.5 meter. Now, linear expansivity is delta L over L1 delta theta. Delta L becomes alpha L1 delta theta. So my change in length becomes my alpha is alpha, that is linear expansivity, multiplied by my L1 0.5, then times what? 40 minus 20. No, times 80 minus 40. Sorry. Multiplied by 80 minus what? 40. That is theta 2 minus theta 1. So delta L becomes 0.5 alpha times 40. So delta L becomes 20 alpha meter. So number 4, on a very cool rainy day when the temperature is 20 degrees Celsius, theta 1 20 degrees Celsius, the length of the steel railroad track is 20 meter. L1 is 20 meter. Then what will be its length? Now, since you are given a length initially and they ask for another length, the length they ask for becomes L2. What will be its length on a hot dry day when the temperature is 40 degrees Celsius? Theta 2 becomes 40 degrees Celsius, and linear expansivity is 11 times 10 raised to power minus 6 watts per Kelvin. This time around, you are looking for the final length. Don't forget that linear expansivity is delta L over L1 delta what? Theta. Abi? So here becomes what? L2 minus L1 over L1 delta theta. So from here, solving this, here becomes L2 minus L1 equals to alpha L1 delta theta. So here L2 becomes what? L1 plus alpha L1 delta theta. L2 becomes L1 then 1 plus alpha delta theta. This is my formula. this is what I'm going to use. So my L2 is unknown, L1 is 20, I have 1 plus alpha is 11 times 10 raised to the power minus 6 times 40 minus 20. That's what I have. 40 minus 20 is theta 2 minus theta 1. So my L2 becomes 20. I have 1 plus 11 times 10 raised to the power minus 6 multiplied by 20. So my L2 becomes 20. 1 plus, here becomes 11 times 20. That will give me 220 times 10 raised to the power minus 6. So my L2 becomes 20. Now 1 plus, I want to change this to natural what? Number. So which means that I have it to be 1, 2, 3. So to raise to the power minus 6, it means it becomes what? Is 0.00220. 1, 2, 3, 4, 5. Okay, it's not complete. I have another is 0, then 2, 2, 0. Then it's complete. So this is 1, 2, 3, 4, 5, 6. The same thing as 220 times 10 raised to the power minus 6. So my L2 is 20. So this becomes 1.000220 when you add. So my L2 becomes 20 times 1.000220. That's giving 20.0044 meter. So that is my L2. That is number 3 and number 4. So we move to number 5. The last question for this part. A brass rod is 2 meter long. That is L1 is 2 meter. At a certain temperature, what is the length? What is L2 for a temperature rise? That is delta theta of 100 Kelvin. And I have linear expansivity to be 1.8 times 10 raised to the power minus 5 per Kelvin. So since it's L2 I'm looking for, my formula remains L2 equals to L1, then I have what? 1 plus alpha delta theta. The same formula I used for number 4. So here becomes L2, here is 2.0, 1 plus 1.8 times 10 raised to the power minus 5 multiplied by 100. That is change in temperature. So the L2 becomes 2.0, I have 1 plus, now 1.8 multiplied by 100. That is 180 times 10 raised to the power minus 5. So my L2 becomes 2.0. Now 1 plus, I will take this natural number, that is 1, 2, 3. So here becomes 0.00180. That is 1, 2, 3, 4, 5. So L2 becomes 2.0 times 1.00180. So my L2 becomes 2 times 1.00180. That is 2.0036 meter. So that is 1 to 5. I'll be solving more questions and also we explain area and linear expansivity. So we'll move to number 6. So we have solved 5 questions earlier. Now this number 6 is also on linear expansivity. But number 7 and 8 is on area expansivity. Number 9 is on volume expansivity. So after I solve number 6, then I will explain area and volume expansivity and I will solve 7 to 10 and then we end the class. For now, number 6. They said the linear expansivity of a metal P is twice that of a metal Q. Linear expansivity of P is twice of what? Of Q. That means P is what? 2Q. A father's age is twice the son's age. That means father is what? 2x. Twice the son's what age. Now, if the linear expansivity of P is twice that of Q, that means Q, linear expansivity of Q it will be what? Q. It will be 1. That will be half. So let's say that means linear expansivity of P will be 2Q. Because linear expansivity of P is twice that of Q. Which means that for Q it was 1, which is Q, and P was 2Q. Then they said, when these materials are heated through the same temperature change, they have the same temperature change, their increase in length is also the same. Then calculate the ratio of the original length of P to that of Q. So I'm looking for L1 of P ratio L1 of Q. Ratio of the original length of P to that of Q. Now, linear expansivity is delta L over L1 delta theta. Now, since it's L1 I'm looking for, I'll make L1 the subject of formula. So here becomes delta L becomes alpha L1 delta theta. L1 becomes delta L over alpha delta theta. Now, we are looking for L1 of P ratio L1 of Q. P becomes delta L over alpha delta theta. This for P. Ratio for Q, I still have delta L over alpha delta theta. So this for P, this for Q. Now this is delta L. Alpha for P is 2Q. Delta theta ratio delta L. Alpha for Q is Q. Now they have the same change in length. You cancel. This ratio, when you have ratio equals between two sets of values or parameters, if they are the same as left hand side and right hand side, you can cancel out, which means Q will cancel Q, this cancel this. I mean, here becomes 1 over 2 ratio 1 over 1. And ratio means what? Division. So here becomes 1 over 2 divided by 1 over 1. That will be 1 over 2 times 1 over 1. That is what? 1 over 2. Mass becomes 1 ratio 2. That is number 6. So let's quickly talk about area and cubic expansivity before we now solve number 7 to 10. For area expansivity, we say area expansivity is the increase in area per unit area per degree rise in temperature. Or you can say it is the change in area per unit area per degree rise in temperature. And it is represented with beta, also measured in per Kelvin. So here I'll say area expansivity is change in area over A1 delta theta. I'll call this equation 1. I also have to be beta. Change in area is final area minus initial area, then A1 delta theta. I'll call this equation 2. It's the same thing what we did for linear expansivity. And I will say from equation 1, make delta A the subject of formula. So if I make delta A the subject, beta is delta A over A1 delta theta. If I make delta A the subject, delta A becomes beta A1 delta theta. I'll call it equation 3. Delta A becomes beta A1 theta 2 minus theta 1. I'll call it equation 4. So from there, and I'll say from equation 2, make A A2 the subject of formula. Make A2 the subject of formula. So here is beta equals to A2 minus A1 over A1 delta theta. Now if I make A2 the subject of formula, it becomes A2 minus A1 equals to beta A1 delta theta. Here becomes A2 equals to A1 plus beta A1 delta theta. A1 is common. Here becomes A1. I have 1 plus beta delta theta, equation 5. So these are the formulas you need. This is where you're looking for volume, area expansivity. Here you're looking for change in area. Here final what area. So these are the formulas you need. Now, mind you, there is a relationship or there is a formula connecting linear expansivity and area expansivity, which is beta equals to 2 alpha, which means that if you are solving or you want to solve under area expansivity and you are given linear expansivity, you multiply by what? By 2 to get your what? Area expansivity. Don't forget that linear is 1, area is square unit, that is 2. So is that 2 used to multiply linear what? Expansivity. So beta is 2 alpha. So very quickly we move towards volume expansivity. So we move to volume expansivity, which is also called cubic expansivity. Now, volume expansivity is an increase in volume per unit volume per degree rise in temperature, or it is the change in volume per unit volume per degree rise in temperature. It is also measured in per Kelvin and represented with gamma. So I will say volume expansivity, this gamma equals to delta V over V1 delta theta. For linear we use L, for area we use A, for volume we use what? V. I will call this equation 1. So gamma becomes V2 minus V1 over V1 theta 2 minus theta 1. I will call this equation 2. So from here, and I'll say from equation 1, make delta V the subject of formula. So if I make delta V the subject, gamma is delta V equals to V1 delta theta. Making delta V the subject, delta V becomes gamma V1 delta theta. I'll call this equation 3. Then from there, delta V becomes gamma V1 theta 2 minus theta 1. I'll call this equation 4. Then moving forward, I'll say from equation 2, make V2 the subject of formula. If I make V2 the subject, gamma is V2 minus V1 over V1 delta theta. Abi, because theta 2 minus theta 1 is same as delta theta. So here becomes V2 minus V1 equals to gamma V1 delta theta. So from here, my V2 becomes V1 plus gamma V1 delta theta. V2, V1 is common, V1 is out. I have 1 plus gamma delta theta. I will call it equation 5. Now, there is a formula connecting volume expansivity and linear expansivity, and that formula is gamma equals to 3 alpha. Gamma equals to 3 1 alpha. Volume is cubic unit, that is just power 3. So exactly use multiply was linear. Now, there is also a formula connecting both was area, cubic, and linear word expansivity. So from here, we have it to be beta equals to 2 alpha, and gamma is what 3 was alpha. I will call this equation 1. I will call this equation 2. Then from equation 2, okay, from equation 1, let's use 1. Make alpha the subject of formula. If I make alpha the subject, beta is 2 alpha. Alpha becomes beta over 2. So if alpha is beta over 2, so from here, I can say substitute alpha equals to beta over 2 into equation 2. So gamma is 3 alpha. Gamma becomes what 3 beta over 2. This is the formula connecting linear expansivity, volume expansivity, and area expansivity. So now we can proceed to solve question 7 to question 10. They said a metal sheet of area, that is A1, 100 centimeters square, was heated through 70 degrees Celsius. That is delta theta is 70 degrees Celsius. Calculate its new area, that is A2, which means that A1 is old or initial area. If the linear expansivity is 0.0000, that is 4 zeros, 17 per Kelvin. Now, looking at this, the first thing is to guess my what? Area expansivity by saying beta equals to 2 alpha. So beta is 2 times 0.000017. So my beta is 0.00034 per Kelvin. Now, I can solve. Okay, we are going to solve with centimeter so that we can also get our A2 in centimeter. So which means that my A2 is A1 1 plus beta delta theta. So my A2, A1 is 100. I have 1 plus beta is 0.00034 multiplied by 70. So my A2 is 100. I have 1 plus 0.00034 times 70. That will give me 0.00238. Because that will give me 2.38 times 7 square minus 3. That is 1123. So my A2 becomes 100. I have 1 plus, okay, that is 1.00238. So A2 multiplied by 100, that is 100.238 centimeter square. Then I move to number 8. That is number 7. I multiply 1.00238. Just move the point twice. So number 8 The area of a square meter is 600 millimeter square. That is A1, 600 millimeter square. Calculate its new area, that is A2. I'm looking for A2 when its temperature is raised by 15 Kelvin. Delta theta is 15 Kelvin. The answer linear expansivity is 1.9 times 10 raised to the power minus 5 per Kelvin. So the first thing I do is to get my area expansivity by saying beta equals to 2 alpha. So beta becomes 2 times 1.9 times 10 raised to the power minus 5. So beta becomes 3.8 times 10 raised to the power minus 5 per Kelvin. So from there, I know that my A2 is A1 1 plus beta delta theta. So we solve. My A2, so my A1 is 600, then 1 plus 3.8 times 10 raised to the power minus 5 times 70. So my A2 becomes 600, 1 plus, so 3.8 multiplied by 70 is 266 times 10 raised to the power minus 5. So A2 is 600, 1 plus, I will change this natural number, that will give me 0.00266. That is 1, 2, 3, 4, 5. So my A2 is 600 times 1.00266. So the A2, so 600 multiplied by 1.00266, that will be 601.1596 millimeter square. So that was A2. So very quickly we move to number 9 and number 10. So we have done with the aspect of area expansivity. So 9 and 10 is volume expansivity. The increase in the volume of 20 centimeter cube, that means V1 is 20 centimeter cube, and the increase in the volume when the temperature is raised by 100 Kelvin is 0.364 centimeter cube. So look at the question. The increase in volume of 20 centimeter cube, this is not the value, of mercury when the temperature rises by 100 is, so they are confused. I cannot say the increase in volume is, so this is the increase in volume, this is the V1, and this is the increase in temperature. Then calculate the cubic expansivity. So gamma is delta V over V1 delta theta. So gamma delta V is 0.364, V1 is 20 times 100. Gamma is 0.364 divided by 2000. So gamma, so is 0.364 divided by 2000. That is 1.82 times 10 raised to the power minus 4 per Kelvin. So we solve number 10, which is the last question. A piece of brass of mass 170 kilogram has its temperature raised from 0 degrees Celsius to 30 degrees Celsius. That is theta 1 is 0 degrees Celsius, theta 2 is 30 degrees Celsius. Calculate its increase in volume, that is delta V. Given that density of brass, density is rho, is my density, is 8.5 times 10 raised to power 3 kilogram per meter cube, and its cubic expansivity is 5.7 times 10 raised to power minus 5 per Kelvin. Now, my formula for this is gamma equals to delta V over V1 delta theta. I'm looking for change in volume. So if I'm looking for change in volume, it means that change in volume is gamma V1 delta theta. I have my gamma, I have my change in temperature, but I don't have V1. Because I don't have V1, that's why I was giving mass and what? Density. Because in physics we know that density is mass over volume. So from here I will get my V1. So volume is mass divided by density. So my mass is what? 170. Density is 8.5 times 10 raised to power 3. So my volume 170 divided by 8.5, that is 20. Then bring this up, that is times 10 raised to power minus 3. Because this is a positive power. Bringing it up because of negative. Then I have to what? Meter cube. Because I have been giving that in what? In meter. So I can go ahead to solve. So delta V, change in volume, becomes gamma is 5.7 times 10 raised to power minus 5 times 20 times 10 raised to power minus 3, then multiply by what? Change in temperature. That is 30 minus what? 0. Delta V becomes 5.7 times 10 raised to power minus 5 times 20 times 10 raised to power minus 3 times what? 30. So delta V 5.7 times 20 times 30, that is 3,420 times 10 raised to power minus 5 minus 3. Here becomes 3,420 times 10 raised to power minus 8. I will convert this to standard form as we did earlier. So here, it means my point is after the last number, and I'm to move the point to stay between the first and second number. So this is 1, 2, 3. Change in volume is 3.42 times 10 raised to power 3 minus 8. Moving your point from right to left is positive. Then from left to right is what? Negative. So change in volume becomes 3.42 times 10 raised to power minus 5 meter cube. So that is the end of today's class. So today we successfully did what? Linear expansivity, area expansivity, and cubic expansivity. So this is the last question, number 9 and number 1 and number 10. So that is the end of today's class. See you in the next class. Please make sure you like, view, and subscribe to my YouTube channel. Thank you.